Hello, everyone, and welcome to today's Tech Talk on Engineering, Wellness, Pandemic, and Beyond. My name is Sherry Adams, and I will be the moderator for today's session. Please note that throughout the Tech Talk, all phone lines will be muted. This will minimize any background noise or feedback that could distract from the presentation. We'll be using the Q&A function. When you have a question, you could submit it through that Q&A function. We'll gather all your questions throughout the Tech Talk and leave some time at the end for Q&A. If your question is related to a particular slide, please include the number of that slide in your question. A PDF of the slides from this presentation will be sent electronically to all those who have registered for today's Tech Talk, and we'll also be recording it, and it will be available on our website under the resource section. Today's presenter is Alan Scott. Alan is a registered architect and sustainability expert with over 30 years of experience and a lifelong commitment to the environment. In his early career as participating architect, he helped launch sustainable design practices in several major firms. Since 2000, as the 13th lead AP, Alan has creatively applied his skills as a facilitator, consultant, project director, and teacher in support of high-performance, sustainable built environment projects in North and South America. His project work focuses on boosting new and existing building performance, decarbonization, occupant wellness, and resilience. So welcome, Alan.
Thank you, Sherry, and hope all of you are well out there and safe and warm with the crazy weather we're having across the country. I have power out at my house right now, but I think we're good to go for technology-wise to move forward with the webinar. I wanted to share a brief word. I am a senior consultant with Intertech, and if you're not familiar with Intertech, we're a global company, been around for over 130 years. Our origins came from Thomas Edison's electrical testing lab, or ETL, as you can still see that logo or that test symbol on your light bulbs. And one of our early components of our company was Pittsburgh Testing Labs, which tested and inspected the original cables on the Brooklyn Bridge. Intertech has grown and evolved over the years, and most recently launched the ProTech line of services and certifications focused on health and wellness in buildings, and health and wellness in all industries, including in buildings, addressing the pandemic and beyond, similar to the topic we're talking about today. With that, I want to kind of launch in and share some context and talk about some specific technical topics that have been on my mind as we think about both our current context in the pandemic and moving on. But for context, it's been over a year since the first reported case of COVID-19 in the United States. In this year, more than 2.4 million people have died globally from the virus, and as of today, almost 500,000 people have died in the United States. So it's been a really significant impact on people who are close to us, and it continues. And now we have emerging variants of the virus coming up around the world and entering here in the United States. Some of them evidence suggests that they might be more virulent in terms of and being more infectious. Some of them might actually be more deadly as well. So we've got some concerns about the virus evolving as it moves along that we have to address. But at the same time, there's lots of cause for hope. We're excited that the successful development and rollout of vaccines is ramping up rapidly. And I'm looking forward to when my time comes up to take the vaccine, probably not till spring, but I'll be in line as soon as it's my turn. I hope you will be as well. Of course, we're not sure that the vaccine will do everything we need it to be in terms of things like vaccine acceptance. Not everybody is comfortable with taking it, and there might be some issues globally with some countries not having equitable access to it as well that could lead to some challenges with the virus We're still not sure about the duration of immunity that the vaccine is going to infer to us, and how soon we're going to have to get a booster shot, what types of modifications are going to be needed to it to keep up with the variants of the virus. So there's reason for hope and optimism. Get a vaccine when you can, but there's also reasons to not rely on that entirely. And here's one example of that. This model that was put together by Dr. Sherman and colleagues at Columbia University, talking about the vaccine rollout and variations on how we address other restrictions. And one of the things that was most stood out most for me today is if we were to lift restrictions now, things like mask requirements and distancing and limitations on gatherings, we would have I think 29 million additional cases of infection between now and the summer, when the vaccine rollout really has its full effect. Whereas if we strengthen restrictions right now, we would expect to have 19 million fewer cases of infection during that time. So it's not over yet, and the vaccine is not the only only one facet of the solution. I heard this description recently by an infectious disease expert, and I loved it and adopted it. It's the concept of the Swiss cheese model. That one slice of Swiss cheese has holes in it, but if you layer one slice over another, the solids and voids cover each other, and you get a comprehensive solution. So, for example, facial coverings or masks, literally and figuratively, have holes in them in terms of their effectiveness. They're highly effective, but they're not perfect. So if you combine those with other solutions, the vaccine, social distancing, and hygiene practices, as well as engineering controls that are going to be part of the topic of this talk today, we get a comprehensive solution that is much more effective. So think of Swiss cheese when you're thinking of layering of effective solutions. And so, essentially the point here is that multiple strategies are going to be needed. We can't rely on hygiene theater and just the superficial measures that make people feel good, but don't necessarily address underlying issues of infection transmission. But we also don't want to throw everything in the kitchen sink at the problem and spend a lot of money and effort at too much of a belt and suspenders approach that might be difficult to implement and might be overkill in terms of addressing it. So we want to think about which selective layers of cheese do we want to layer up to get the best effect with the lowest amount of effort. I think you've all familiar with this now, so I won't spend too much on it, but certainly there's been evolving understanding about the routes of transmission of viruses, including the SARS-CoV-2 virus. Early on, there was perhaps too much emphasis on the fomite transmission, or the contact transmission of the virus, with these droplets falling on surfaces or within close contact to one another. And that's still important, and we need to address it. But one academic presentation I saw recently described that as about a 5 in 10,000 chance of fomite transmission. So it's very low. Whereas we understand that airborne transmission is much more likely to be the route for infections going from one person to another, and the one that we should spending more effort addressing. And it's not just about the SARS-CoV-2 virus. There, the rhinovirus, the common cold, influenza, other common viruses that we come into play, and then some of the other ones like measles that we've seen outbreaks of recently, are all airborne, rely on airborne transmission. So some of the same things we might do to address SARS-CoV-2 transmission can also be addressed, or also help with all of these other things that we've been dealing with before and would like to deal with less. just the impacts on business and schools and other things from common colds and flu, not to mention the serious illnesses and deaths caused by the flu each year, are significant, and why not address them as well? And stepping back, I want to think about a broader consideration about wellness in the built environment. I really appreciated the wise words of Professor Vanden Wijmelenberg at University of Oregon, who shared these astute observations about designing for 100-year floods for a long time. So maybe we need to design for the 100-year flu that might not be 100 years before we see the next one. And not just thinking about designing buildings to reduce, keep people from getting sick, but how can we design and operate buildings to help people to be well? Can we support holistic, strong immune function in adults and people, so we can keep ourselves healthier and stronger against any kind of pathogen that might come along that we would be exposed to. So I think that we want to take that more holistic approach in our design, construction, and operation of buildings. Another perspective I ran across a few years ago, and I'd love to bring this up and share it, is this study that was done about the factors that influence health outcomes. And oftentimes we think about having access to good doctors and clinics being a critical part of health outcomes. And that's, 20% of the benefit. So we don't want to ignore those things. But there are all these other factors that make up the other 80% of positive health outcomes. And that includes the built environment and health behaviors and social and economic factors. And one of the things, since we have a built environment focus here with design and engineering in buildings, and we can see that that's about 10% here. However, the built environment affects health behaviors, can influence health behaviors, giving clues about positive behaviors, and the built environment can also have a positive effect on social and economic factors for people in both their living and work environments. So by a more holistic health approach and wellness approach to the built environment, we can have significant impacts on many aspects of health outcomes. And there's good reason for that. Before the pandemic, there were trends towards healthier buildings and wellness in building design and operation. And those are just being accelerated in our response to the pandemic. And there's good economic and social reasons for that. You probably are familiar, but it's worth reminding people about the cognitive function study that Harvard T.H. Chan School of Public Health conducted a few years ago, finding that green buildings that included enhanced ventilation strategies resulted in significant boosts in cognitive function. There are also many older studies of things like schools with higher academic performance in students when they have well ventilated classrooms, and then we have these significant financially, but maybe less tangible and direct benefits of the demands that employees are putting on employers to say we want healthier environments. And I think that's only going to be magnified by this experience of the pandemic. And that moves upstream into tenants demanding healthier buildings from landlords. So we're going to be seeing this whole aspect of attracting and retaining both talent as well as tenants being focused on the healthy building aspects that we put in place. So how do we do that? And some of in addition to some of the softer measures, there are a number of engineering controls that we can put in place to address health and wellness, and specifically address some of these air quality issues and airborne transmission of pathogens. ventilation, filtration, obviously, some discussion about sanitization. And then I want to kind of weave in some of the trends we've been seeing in smart buildings and how that might be accelerated and emphasized by our response to the pandemic and moving forward. So all of these represent those slices of Swiss cheese that we're going to pile up to come up with a comprehensive strategy that works well. One of the things that I think is important to note is that because of, there's a lot of fear and concern and misinformation in the pandemic, and I think that's led to pushing of a lot of miracle solutions to help address the virus and keep people safe. It's important to understand that some of these new technologies are good, but it's also important to recognize that some of them have not been sufficiently vetted and might not be the most effective ways at solving the problem that we're trying to get to. And there's the potential also of creating other health and safety hazards with these technologies. So the bottom line, we want to read literature carefully and look for independent testing of the efficacy of these technologies to validate claims. And I think keeping it simple is a key element that I always focus on. Using proving strategies and simple strategies first before we go to more exotic solutions. And of course, one of those is certainly thinking about improved ventilation. I think it's kind of worth noting that the ASHRAE 62 standard talks about acceptable indoor air quality as opposed to optimal. And so maybe we need to look beyond ASHRAE 62.1 minimums and think about improved ventilation that is most effective in its supply and distribution in the space to remove pollutants, bring fresh air to where the breathing zone where people are, and not resulting in cross-contamination. One of the things that I'll first caveat this by saying I'm an architect, not a mechanical engineer, and so some of you probably know more about this topic than I do, but I've talked to lots of engineers, done lots of reading, looked at lots of studies, and trying to educate myself on this topic. And it seems like there's not enough research and investigation and analysis has been done to come up with what is the optimal way to do this. I have seen some really interesting computational fluid dynamics studies showing that, for example, that displacement ventilation tends to result in removal of contaminants from the breathing zone more quickly and less potential for that mixing of air to result in spreading pathogens from one infected person to other people in the room. I also know that there are some factors that would influence that one or the other. I've seen that in addition to some of the traditional CFD modeling tools that are out there, there are some new ones being introduced, like one called Fatima that my friends at Code Unlimited recently did some simulations to look at a simulated cough and how the particulate matter from a cough distributed through the room, through the airflow, and looked at that with different types of diffuser and return locations in the space. So I think that we have there's room for us to do more exploration about what's an optimal way to ventilate spaces to keep people healthier. The other element that goes along with ventilation is filtration, and thinking about using higher quality filters in spaces. I'm going to be sharing with you limited results from an investigation we did in an office building recently that look at the various strategies that we're talking about here. So I'll get to that in a moment. But I think that the one key element is that the typical filtration in buildings that's primarily meant to keep dust off the coils is not necessarily what we want to be doing for optimal health in buildings. That MERV 8 filter that only has a 50% removal rate for PM 2.5 particulate matter, it just doesn't cut it in terms of both removing particulate matter, which is a respiratory irritant, as well as virus particles and other pathogen particles in the air. So thinking about higher efficiency filters like MERV 13, where that's possible, does have a significant impact on keeping air cleaner and keeping people healthier in a space, and is a good complement to that balance of an increasing outside air rates and improving ventilation. One of the things that we've been looking at in retrofit situations is we're not always able to increase the filter efficiency significantly in buildings, and in some cases the count on that being a primary means for keeping pathogens from transmitting from one person to another in more densely occupied spaces. So I think that there are situations where portable HEPA air cleaners are appropriate to deploy in more extreme circumstances like this, where we're dealing with a dangerous virus in a pandemic. So I have seen that a simple HEPA air cleaner, no extra bells and whistles of UV or catalyzing devices on them, maybe is necessary, can be a great supplement to what you can do with the base building mechanical systems. So analyzing all of those solutions together is really important. And in some of the work that we've been doing with Engineering Economics Inc. In looking at contaminant or pathogen risk reduction in buildings, we've been focusing on the effective air changes per hour and how to stack up increases in outside air ventilation, improvements in filtration, plus in some cases using in-room air cleaners as a way to reach an effective air change that's better than the minimums that most buildings are facing. You can see here a simple illustration of the significant improvement in the time to remove 99% of contaminants from a space when you move from 1 air change per hour to 4 air changes per hour. But you also reach a point of diminishing returns. So in that 4 to 6 ACH range, you're seeing significant improvements over a baseline, but you're seeing it gets pretty incremental after that point. So finding the right balance of how far to go with those strategies and which mix of strategies gets you there in the most effective way is an important part of the approach. Just a couple of examples that EEI pulled together and shared with me. In this case, an office building, using the assumption that people are wearing masks and using social distancing, so you have a reduced occupancy in that space, and still with typical ventilation in that space, you've got a 4.5 risk of infection in an 8-hour day. By increasing that effective air changes to 6, you drop that down below 1% risk, which is a much more acceptable level of risk to be thinking about in terms of reasonable precautions. In this illustration of a high school classroom, did a similar analysis looking at in a typical ventilation, same situation with half the number of students that normally be in that classroom, you still have a 2.5% risk of infection with typical code ventilation in the classroom. By increasing that ventilation rate, doubling it, or you're getting to a 1.5% risk. And by increasing ventilation and upgrading filters, you're getting to be just above a 1% risk. So it's that stacking of strategies to get to a practical solution to get down to 1% risk or below. You can also look at adding in additional strategies for sanitization of air. The UVGI is a technology many of you are probably as or more familiar with than I am. It's been around and used in healthcare significantly for a long time. There are issues about can you get enough intensity of UV light in the right space relative to the airflow past it to do the get the sanitization you're looking for airborne pathogen particles, and can you do it in a way that's safe, that in the process of maintenance you're not exposing people unnecessarily to the risks of UV exposure to the eyes and skin. And of course the other choice besides in duct or in air handling unit installation is upper room ultraviolet germicidal and eradication, or UVGI, upper room UVGI. And I have started to see a little bit more information on far UVC, which is the narrower wavelength that is deemed to be safe for exposure to humans. I think that perhaps this is safe and an effective way to get sanitization in certain spaces where risks are higher. But I think that you need to be cautious about what's going to happen with exposure to people, as well as the materials and finishes in the space. How are those going to react over time to the UVGI? And of course, with the appearance of some of these images, I was reminded of Stranger Things, and I think the jury's still out on whether or not UVGI can help you with eliminating demigorgons as well as viruses. And I get asked a lot, and I hear lots of discussion about ion generation technologies or NPBI, needle point bipolar ionization. These units have been promoted for various things over the years recently, particularly around air quality. One of the primary ways that they function is by the charged ion particles cause particulate matter in the air to agglomerate and either precipitate out of the air or be captured more easily in filters. So it has some potential air quality benefits there. There have been some laboratory studies that suggest deactivation of pathogens as a potential benefit, but it's not clear to me and to people more expert than myself whether or not some of those situations can be adequately transferred to a real world situation, and if we can count on them to be effective in the environment. So this is one we want to think about. It could be a game changer, but we want to use caution in thinking about its efficacy relative to other strategies. We recently conducted air quality testing before and after in an office building, a multiple floor office building. In this building, it's a 52-story building. On 2 different floors, they installed NPBI in the air handling unit upstream and downstream of the coils, and in the 2 different floors. On another floor, they installed a UVGI system in the air handling unit, and then they also upgraded and tested 1 floor with MERV 15 filters. So we went in and did before testing, before these technologies were activated on these different floors, and then after they were activated and had a chance to reach a steady state, we did sampling for bioaerosols, particle counts, as well as testing for aldehydes and ozone on the floors with the NPBI system. One note I'll share is that this building already was using MERV 14 filters as their standard filter, so our baseline was already quite high in terms of particulate removal from the air. We're still crunching the numbers and the data we got back, so I don't have full results to share with you. We did find that that the NPBI systems perform slightly better in terms of removal of bioaerosols and particulate matter compared to the other technologies. But because our baseline was already so low with MERV 14 filters, the difference was not that significant. If I had in a perfect world, I would have loved to have done this experiment with MERV 8 filters as the baseline and seen a more significant comparison. But my quick takeaway is that just having above standard ventilation and higher efficiency filters gets you a long way towards better air quality without adding additional technologies. I'm close to wrapping up here, and I'm looking forward to having a discussion and questions about these. Just the last final point I want to share is about the bringing in of smart building technology into this whole process. I think that because you can't be conducting studies like the one I just talked about on a regular basis, and certainly there's not a conclusive way to do real-time monitoring for viruses. We have to look at proxies for air quality. Are the systems and buildings operating the way we want them to be? And so things like carbon dioxide and particulate matter can be proxies for how well our ventilation system is working at keeping the air clean. And I think that because the quality of sensors has gone up while the cost has gone down, I think that we'll be seeing more real-time monitoring of air quality in buildings as a way to maintain and improve on air quality over time, addressing issues that come up. And the other piece is I think that some of the other health and wellness aspects are going to be integrating into these user interfaces, touchless controls, and addressing temperature and humidity and lighting preferences, as well as the other user interface aspects of the hybrid work environment where people are working from home or remote part of the time and working in the office, and all of the scheduling issues that come along with that. I think we're going to see a whole new world of integration of smart building technology with protecting health and wellness of occupants. And so I'm excited about what that has to offer, with the one caveat that I've been hearing that some of these technologies open up some doors for hackers to get in. So we want to be careful about cybersecurity while we're adopting some of these technologies. And I have a lot more to learn about those aspects. So it's an area of great interest and study for me. So kind of to wrap up, I want to kind of emphasize that we're not just focused on airborne viruses. We want to think about holistic approaches to health and wellness in buildings that address those airborne pathogens, and not just COVID-19, but all the other things that can impact health and absenteeism and other aspects in the built environment. Indoor air quality is going to be a huge part of that element in addressing wellness in buildings. And we want to think about the simple solutions that have long-term benefits, not just implemented because of the pandemic, but moving beyond that into a new world of health-promoting buildings. So with that, let's do some question and answer.
Thank you, Alan. We really appreciate your time and expertise. I'm not seeing any questions at this moment, but I have a couple of quick announcements, and if question comes in during that time, we'll let you know. Just is an announcement that Alan may have mentioned, he'll be expanding a little bit more on this topic at our spring webinar series that will start up next month in March. So you could go to the website soon. All the information will be added hopefully later this week for that series. Also, if you haven't already done so, don't forget to renew your membership so you can continue to receive these informational tech talks as well as other valuable benefits. So let me just double check the, okay. Not seeing anything there. Any questions? Anybody? Feel free to leave in the Q&A section. And if anything comes up after you review the presentation and after you review the recording, please let me know. You could always email me your questions at sadams@bcxa.org, and I could get them over to Alan, or tune in, like I said, for next month for this webinar series as well. And Alan, thank you again so much for your time and expertise. And on behalf of the BCA, I'd like to thank everyone for participation in today's Tech Talk, and have a great day and stay warm for those of you in the cold weather.
Yeah, thank you, Sherry, and thank you all for your attention. Have a great day.
You too. Bye-bye now.
Bye-bye.